All right, guys, today we're going to look at doing some of the hands-on parts of learning about acids and bases. But before we get into the actual math, I wanted to go ahead and recap some of the concepts and terms just so that we're on the same page. So let's get started. First, we'll look at making sure that we understand this value of pH. And pH is used to measure H protons, or hydronium ions, if you will, hydrogen ion concentration. And so if something has a large concentration of these little ions, it's going to be indicative of a pH value that'll read that out. So the one thing I really wanted to highlight is that when you're talking about pH, the pH range lasts between 0 to 14 for a range. Now, for the purpose of this lecture, it does exist within that range, although if you were clever, there are values that may exist outside of this. But for the purpose of what I'm discussing, you want to focus on just that 0 to 14 range because there's going to be calculations associated with that. And when you talk about that, there's a very popular equation that goes with pH that relates pH and its value to that measured hydronium concentration. Now, that equation looks like this, where pH is equal to the negative log of your H plus concentration. Now, sometimes you'll see it that way. Sometimes you might see it written like this, where you have pH is equal to the negative log of this guy. And if you don't know what this guy is, it's H3O plus. H3O plus indicates hydronium ion. That's hydronium ion. And you're going to want to be familiar with that term. Now, when something is an acid and it's regarded as being an acid, we're saying that it has both, has a majority of acid protons. So if you want to imagine a compound in a container, a lot of times I give people a physical description of something that has a imagery that goes along with that. Now, let's understand this. First, anything that has a pH that is basically less than 7 is going to be an acid. Anything that has a pH that is greater than 7 is going to be a base. Anything that has a pH that is really, really close to 7 is going to be neutral. And what does that really mean pictorially? Well, it means this. If I'm looking at 3 containers, and I'll crudely draw 3 containers here, and in these 3 containers, imagine, if you will, they're roughly the same size. One container would have these little molecules, and I'm going to draw these using, little round balls. Like this is blue, 1, 2, 3, 4, 5, 6, 7. And then I'll give this 3 of them, 1, 2, 3. And that's green that I just gave it. And then I go here and I'm going to say 1, 2, 3, 4, 5. And I'll give this one 1, 2, 3, 4, 5. And then I turn around and I give this one 1, 2, 3, 4, 5, 6, 7. And then I turn around and add 3 blue ones, 1, 2, 3. Each of these represents a certain kind of solution. Now let me go ahead and draw a legend so I can highlight what I mean. Let's imagine that the blue stands for base molecules, molecules that act like bases. And let's imagine, if you will, that the green ones operate as acid molecules. Well, when we're talking about a solution that's acidic or basic, we're saying that usually there's some mix of both of these molecules present in some way. Now, for this one might have a pH value that might be, I don't know, leaning more towards the basic side because it's blue. So this solution would be considered a basic solution. Now, in terms of numbers, I just arbitrarily drew the molecules, but we could assume this could have a pH easily of 10 because it's basic. Now, if you're looking at the image, it has base molecules, which are blue, but it also features the green dots as well to kind of highlight or show that you're still dealing with the idea that there is some acidic content present. Now, if we look at this one right here, we notice there's an equal number of 5 green ones and a number of 5 blue ones. And with that kind of solution, it ends up being a neutral solution that would have a close pH to about 7. That's what we're saying. So this compound here would be what we consider neutral. And then if you go to the right one, you notice you have 7 of your green and maybe 3 blue, but it's overwhelmingly green, which means that it is going to be acidic overall. And then you could, premise or propose that it might have a pH of 3. Now the numbers that I'm assigning, these are arbitrary numbers. They are numbers that I just made up, but they're there to extract a relationship where you're seeing that if it's acidic, the value is going to be less than 7, and we have more of these little green molecules that are acidic than the blue molecules. And so I want you to visually, hopefully, be able to relate those two concepts, because the understanding is that even though something's acidic, it's not just all acid protons. It does have some basic compounds or basic molecules that are still going to be present. And you want to be aware of that when you're dealing with this pH, because later when we explore this relationship, it's going to help hopefully with some of the math relationships. And since I'm already talking about that, let me go and start by simply putting this equation on there. I've talked about pH, and I did not mention its counterpart, which is something called POH. Now POH also has a range between 0 and 14, but it's the complete opposite of pH. It is used to measure hydroxide concentration. And so the ion of choice here, and I didn't finish writing concentration, but you get the gist. The hydroxide is represented with OH minus. That is hydroxide ion. And you want to be familiar with that term as well. So you have hydroxide ion. We talked about hydronium. pH measures hydronium. POH measures hydroxide ion concentration. And it turns out any compound has a combination of 2 of those ions that are being measured cooperatively. And so we're able to extract a relationship where pH plus POH actually equals a value of 14. And so if we have a pH value, mathematically, we should be able to extract a POH value. So what does that look like? Well, simple. It means that if you know the pH of something is, let's say the pH is equal to 3, well, conversely, the POH is going to be whatever the value is of 14 minus 3, which is equal to 11. Now, notice this value. When we look at pH, pH is 3 and the POH is 11. If I asked you if this was an acid or base, hopefully you'll be able to conclude that this compound is indeed an acid. And the reason we go with that is we're going off the relationship we talked about here, when you talk about pH being less than 7 is an acid. Now, if we took that and applied that to the POH concept, the POH concept would be written a little bit differently. It would mean that POH, when it is less than 7, would actually be the opposite, which is a base. And it would also mean that POH, when it is greater than 7, is an acid. Now, the only thing that stays consistent is that if your POH is equal to 7, well, it is neutral. Just like with pH is neutral. But notice the key difference here between those two and then these two. So you want to be mindful of that, because questions that can be asked are, hey, you're given a solution which has a pOH of something that's equal to 2.5. Is that acidic, basic, or neutral? Well, according to this information here, if something has a pOH of 2.5 and that's less than 7, that means it registers as a base. Now, what can you tell us about the pH of something that has a pOH of 2.5? Well, easy. If you take the pH and you're looking at it, it really just represents the value of 14 minus 2.5. And so if you took that value and you got your 14 minus your 2.5, you end up with 11.5, which for pH, that is a base because it has a value greater than 7. So you want to be familiar with those concepts as your starting point, because you're dealing with pH and pOH, and questions are going to center around them. Also keep in mind that pH measures your hydronium ion concentration and your pOH measures your hydroxide ion concentration. And just in case I didn't really throw that out there, I want you to understand that these brackets here usually refer to concentration. And if we're talking about concentration, a lot of times you're talking about this concept called molarity, which should be a familiar term, because molarity is a measure of concentration of a solution. And so when we're looking at the pH and pOH, that's their relationship. But there's a little bit more that we can